Hello ladies and gentlemen, I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one's entitled Planet X Larger Than the Sun on Collision Course with Earth. What happens? Now, Planet X system stellar cores have been observed close to the Sun on many occasions. These objects come into the solar system as comets and must therefore enter the solar system along extremely eccentric orbits, which must have taken them past the Earth's orbit. Since comets have been observed for thousands of years, these objects must have been coming past Earth's orbit for thousands of years. So it is important to consider what happens when one heads towards the Earth. And you can see some of these objects. This one was about 7 times larger than the Sun. The size of the Sun is indicated by the white circle. You can see some of this plasma coming from the Sun is actually in front of the object, so we know it's very close to the Sun. And here's another one. There's CME material going out towards the object. The same with this one. This one also seems to be about the same size as the Sun, and so does that one. So these objects actually induce matter creation events in the Sun's core, which then results in CMEs, or coronal mass ejections. And the objects approach the Sun as comets. So you see a comet there. Now, Planet X system stellar cores approach the Sun along different orbits, and only the largest objects have a large enough electric potential to get to the Sun. This is because the Sun has energy levels, which decrease in energy level as we move away from the Sun. And if an object tries to get closer to the Sun than its energy level, it is repelled. The greater the size of an object, the greater will be its electrical potential, or proton density, which also determines the object's energy level. So only the largest objects have a high enough energy level to reach the Sun. And you may look at Article 566 entitled Planet X Creating Sinkholes and Effects on the Human Body. And this is illustrated by this diagram. So you have 2 different stellar cores coming into the solar system. You can see the planets, Mercury, Venus, Earth, Mars, and Jupiter. And the smaller one will have an energy level or an average electric potential, which allows it to just get inside Earth's orbit. There's Earth's orbit there. So what happens is it comes in, it gets to a point where it cannot approach the Sun any further, so it's repelled. So from that point on, this point becomes the perihelion position of its orbit, and from that position on it gets further away from the Sun again, but it will follow an elliptical orbit that brings it around each time. So it goes through that particular point of its orbit, its perihelion position. So, and the larger object will be able to keep on approaching the Sun until it too is repelled away. So, and that depends on its energy level or its electric potential. And this one can therefore get much closer. And the larger the object, the higher its energy level. So the larger objects will be able to get closer to the Sun. But then this also means that sun-diving comets, which go straight for the Sun, have to be very large stellar cores. Now, if a stellar core's perihelion position is inside the Sun's atmosphere, it will connect to the Sun as if it is a part of it for a period of time. It may also remain stationary with respect to the Sun's surface until a drop in electrons in the Sun's atmosphere results in it being ejected, and it thus goes back to its long elliptical orbit. It may also be ejected as a result of a CME. Now, in addition, matter at a certain proton density seems to only interact with matter of comparable proton density. So stellar cores of different sizes interact with matter at different depths within the Earth, which is why only the largest stellar cores give rise to sinkholes. Now, this is illustrated here, and what you see, this is the Earth, and we see 2 stellar cores, a small one and a larger one. And this one only interacts with the Earth's atmosphere, which is at a lower energy level than the center of the Earth. The energy level increases as we move down towards the center of the Earth. In other words, the potential the electric potential and the gravitational potential. It's the same in celestial objects, in living celestial objects, but not the stellar cores because they are dead. So they are much lower in gravitational potential. You can see this one's VG20, then electric potential. This one has the electric potential, which is the same as the Earth's atmosphere. That's why it interacts with the Earth's atmosphere. So its layers here have a proton density which is equivalent to the proton density of matter in the Earth's atmosphere, whilst this one has matter in there that has equivalent proton density to matter that is deeper within the Earth, this matter here. So it interacts with it, but it's not able to interact with the atmosphere because it has no matter of that proton density or that energy level. Now, what will happen when one of these very large stellar cores is on a collision course with Earth? These objects have a much higher energy level than the Earth, or are at a much higher energy level than the Earth. But yet it is impossible for them to pass right through the Earth without affecting it, as both are solid objects. And since celestial objects tend to repel each other, just like protons in the nucleus repel each other, it is to be expected that the two objects will repel each other before collision occurs, which indicates that even though the Earth is at a much lower average energy level than the very large stellar core, there must be some matter within it, which is at the same electric potential as some of the matter in the stellar core. And this means that there has to be matter within the Earth that is at the same electrical potential and thus proton density or energy level as the matter in the stellar core. And since the same argument would arise with any object, no matter how large, on a collision course with Earth, this suggests that within the core of all celestial objects remains a layer deep inside which is at the highest energy level possible. And that's living celestial objects. The stellar cores are different. And that's the highest energy level possible in the universe. In other words, each core retains a piece of the original supercore that all celestial objects in the universe came from. You may look at Article 561 for more details on that. Now, the central maximum energy level matter at the center of a core will be smaller in smaller objects, but there is still some material at the original electric potential and thus at the original proton density of the original supercore. So here we have the stellar cores. The stellar cores are just the core of what was once a whole celestial object. So they don't have outer layers. And so what we see here is what was originally the core of the living celestial object. It would have had outer layers on top. But when it died, it lost its outer layer, so now you only have an outer layer with this particular energy, which is illustrated by the color that we use here. So the lighter the color, the lower the energy level, the proton density. And so the stellar core had a core, well, as a living celestial object, as a star, it would have had a core at this energy level. Okay, this would be the size of the inner part, and it would be at the maximum energy level possible. But then when it died, some of the electrons moved in and combined with the protons, became neutrons, and that decreased its proton density. So what happened was the outer layer became less dense in protons, and so its energy level dropped. And then the inner core, some of it, its energy dropped because some of its protons combined with electrons. And then it was left with a very small, compared with its initial size, still much larger than the Earth because it's a very, very large stellar core, a much smaller size in a spherical region that is still at the maximum proton density or energy level. And here's the Earth. The Earth is a tiny object, but it still has a core that has at its center a small region that is still at the maximum density, proton density or energy level possible. So that means that the stellar core will be able to interact with the Earth at these deep levels. But this top level in the Earth, it's at a level of energy which the stellar core does not have. So this part of the Earth will not interact with it, but they will still repel each other. And so the Earth and the object will move away from each other if a collision is about to occur. So small stellar cores, which seem to only interact with Earth's outer layers, may have become depleted to the point that they lost the maximum density layer completely. So they have no maximum density layer, probably have lost most of these high density layers and only have low density layers, which is why they interact only with Earth's outer layers. Now, the larger ones will always interact with the Earth's deeper layers, so they will be able to induce matter creation events in the Earth's core, and they will attract magma, whilst the little ones will not be able to. So this also makes sense in terms of creation of celestial objects, such as planets, which form inside stars and are then ejected. In order for a star and a new planet to remain connected and thus interacting with each other, the new planetary core has to retain a piece of the parent core at the same electric potential or proton density or energy level as the parent sun core. The new planetary core will thus use its energy to create new matter, but it will always retain a piece inside it that is just as dense and as energetic as its parent star's center. Thus, the Earth will interact with all size stellar cores, although the very large objects will not be able to get much in terms of energy or material from such a tiny planet as Earth, and will thus tend to go to the Sun for energy and electrons. Since there is matter within the Earth that will react to the presence of such an object, if any pass close to the Earth, matter creation events will be induced deep within the Earth, which will result in volcanic eruptions of earthquakes. The Earth will also most likely be tossed around like a ping pong ball as the object passes close to it. However, the Earth will return to its orbit after the object passes, since the Earth's orbit, as well as any other celestial object's orbit, is determined by its average energy level. Since the Sun is no longer shining due to its current state of electron depletion, it is also likely that more and more, as well as larger and larger stellar cores, will find their way to the Earth with cataclysmic consequences for the Earth. And this illustrates what happens when a new planet forms. It's ejected as a core from the star, from its parent star, and it will have the highest density, proton density material from part of its parent's core and another layer with at an energy level just below it. And then the core, once it's outside the body of its star, will start forming new matter, creating new matter, and it starts forming its outer layers. And that causes its gravitational energy to drop to a lower level, and that then causes the electric potential to also drop, and its average proton density will drop, and that means that the core will now have a smaller sized inner region that is at the same proton density as the core in its parent star, but it's now much smaller, so that causes its average proton density to drop and therefore its average energy level. So in conclusion, all celestial object cores have at the center matter which is as dense and energetic as plasma at the center of the original supercore in the universe, from which all celestial objects come from. This is the only way for objects to avoid colliding with each other. So a very large stellar core on a collision course with Earth will be repelled by the Earth, and the Earth will be repelled by it, so that no collision is possible. However, the object will only be able to interact with the Earth's core and have no effect on the Earth's top layers. The approach of such large stellar cores to Earth is likely to lead to cataclysmic volcanic eruptions and earthquakes. And these are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.